Good morning, class. Today's topic is mathematical induction. Before we start this class, I hope you all are paying attention with your textbooks now and your exercise book. As we go along, I want you to understand the key concepts that we are going to learn today. It is important for you to understand and have prior knowledge on expanding and simplifying expressions. Okay, we will be using your prior knowledge on expansion and simplification. And by the end of this lesson, you will be able to achieve the mathematical induction. You will be able to prove the mathematical induction on the context of sum of sequences. Is that clear? So basically, in today's lesson, you all should be able to prove the statements. Okay, in mathematical induction, we are proving statements. Before we begin with the notes, I would like to ask you to imagine a scenario. Okay. Imagine in your village you are distributing coconuts, okay, among 50 people. Okay, first person takes one coconut, the second person will take two coconuts, and the third will take three, and so on. Okay, so do you all think that there is a easier way to calculate this instead of adding them one by one? Okay, now that is where mathematical induction, okay, sum of sequence comes in. Is that clear? Now, there are only four conditions, okay, in proving these statements. There are four conditions that you are going to satisfy in order to conclude that whether it is true or not. Okay. First of all, you must know that mathematical induction is the method of proving statement that involves a variable which takes on the value of natural numbers. Okay. Now, it is important to note that we are dealing with natural numbers here. Okay. And from your prior knowledge, you all know that natural numbers begin from 1. Okay. Natural numbers are counting numbers. Is that clear? Now, when you are going over these four conditions, you must consider them as the staircase steps. Okay, you all must have seen the staircase steps. All right. Now, you are going to take the first step. Okay, we consider that as our base case. Okay, show that the formula is true for the first number. All right, where n is equals to 1. You are going to substitute the value of n as 1, and you are going to check from the right hand side. From the right hand side and left hand side. Okay, that is our by step. Second step comes the induction hypothesis, alright, where we are going to assume it works for n is equals to k. So in this particular set, what we are basically going to do is we are going to substitute k in place of n, okay, in the statements, alright. And the third step is one of the most important steps, alright. That is known as the induction step. From the base case to the induction step is one of the most important part, because as I said, the staircase, first step is our base case. Now moving from one step to the other step is our will be our induction step. Okay, from the base case to the next. If you are able to go from one step to the other, you will be able to climb any staircase regardless of how high it will be. Okay, you will be able to climb forever. That is how we are able to prove that the statement is correct form in under mathematical induction. Alright. So we are basically in induction step we are basically going from k to k plus 1. Understand? Now it is very important to know and understand these as the steps that we are going to take. You will be able to understand this better once we go over this example that is provided, because in the fourth step we are just going to conclude. Okay, therefore it will be true for all natural numbers. Provided you can make these statements provided you satisfy all these three conditions. Is that clear? Do you all have anyone has any questions regarding whatever we have just discussed? Now we will be moving on to the example here. So in order to solve, we have this statement. Okay, you can consider this as the scenario that I have given regarding the coconut distribution in this village. Okay, first person will take 1, second person will take 2, third person will take 3, and it will go on. Okay, so we have rewritten this as n into n plus 1 divided by 2. All n is element of natural numbers. Is that clear? So we are going to prove whether this statement is correct or not. Okay, as I mentioned in your learning outcome today, you are going to know the sum of sequences. So according to the statements, first step will be n is equals to 1. Okay, in the left hand side we can say n is equals to 1. Okay, this is for left hand side. Now for the right hand side we are going to state n is equals to 1. We are going to substitute 1 in place of n. Therefore, we can write this as 1 into n into 1 plus 1 divided by 2. Is that clear? Now this is equal to 1 times 2 divided by 2, which is going to give us 2 divided by 2, which is equals to 1. So left hand side is equals to 1, right hand side is equals to 1. So we can conclude that left hand side is equals to right hand side. So this is how we have proved our first step. That clear? Now the second step involves n is equals to k. Now we are going to replace k in place of n, okay, using the equation that is given in the statement. Is that clear? So by substituting that, we can directly write that as k into k plus 1 divided by 2. Is that clear? Now we are going to move on to the most important step of our concept over here, okay? This is where we are going to prove that n is equals to k plus 1, whether it can work for k plus 1 as well, okay? Now for this you have to imagine whatever I have discussed, okay? You have to relate to the concept that has been discussed to you. You must understand that k is a number now, which is, okay, is a number, one number less than n. Okay, k is one number less than n. For example, when I said that the coconut distribution is among 50 people, you should know that k value will be 49 in this case. Understand? Because n is equals to k plus 1. So k is one number less than n. So we are going to rearrange, okay? We are going to rewrite this statement, okay? Now it will go up till, say for example, the coconut distribution in your village, it will go from 1 to 49, because we will write k. 1 to 49 plus 1, which is 50. We are going to rearrange it in that particular way. Okay, so if I rephrase this, I am going to write it as 1 plus 2 plus 3, and it will go up till k. Understand? Because we are satisfying this property. Then we will have that written as k plus 1. Alright, this will become our left hand side in this case. Okay, you can put this in brackets as well. Alright, nothing has actually changed because we know that this k value will come before n. Okay, so n is equal to k plus 1, and this will go up till k. Is that clear? In this side we will have n into n plus 1 divided by 2. Alright, now we will first solve for the left hand side, and then we will solve for the right hand side. Okay, in the right hand side it will be straightforward. We are just going to substitute this in place of n. Okay, but in the left hand side we have to first rearrange and simplify. Is that clear? Now we will have 1 plus 2 plus 3 going up to k. Now in order to solve this, we know that this thing can be rewritten in this form here. Okay, so 1 to 3, and it can be written in this way. So this can also be rewritten in this way, but the only thing different will be that this one ending with n, so here n, this is ending with k, so we'll have k in place of it. So we will rewrite that as k into k plus 1 divided by 2 plus k plus 1. Now you know that the denominator for this is 1, and now I would like you to use your prior knowledge and expand and simplify. Okay, and how will you do that? You will use the 3 arrow method. Okay, this will be multiplied to this will be multiplied to this, and these two will be multiplied to each other. Alright, when this will be multiplied to this will remain the same. Okay, so we have k into k plus, and we have 2 into k plus 1, and the denominator will become 2. 2 times 1 is equal to 2. So both of the denominator is the same, we can put a common denominator there. Now we are going to expand this, which gives you k squared plus k plus 2k plus 2 divided by 2. Now these two are the like terms here. Understand? Now since these two are the like terms, we can add those two. K will be equal to k plus 3k plus 2 divided by 2. Now what I want you to do here, before simplifying this, I want you to factorize the numerator. Is that clear? Now how do you factorize numerator? N times k, then 2 multiplied by 1. Okay, now you will check. K times 2 will give you k, and then k times 1 will give you k, which is going to give you 3k. Now this is equal to this over here. Okay, so we can write it, but when we are going to write this, we are just going to consider this line over here. Therefore, when we factorize the numerator, we are going to rewrite it as k plus 2 plus k plus 1 with the numerator 2. Is that clear? This is for the left hand side. Now we are going to solve for the right hand side. Okay, so consider this is the left hand side and this is the right hand side. Is that clear? Now we are just going to substitute k plus 1 into k plus 1 here plus 1, okay, divided by 2. Now 1 plus 1 will be k plus 1, k plus 2 divided by 2. Now this and this are equal to each other. Therefore we have proved that the left hand side equal to the right hand side. So the third property is also satisfied. So since that is particular, the fourth step will be conclusion. We will state therefore statement is true for all natural numbers. Okay, so today what we have to do is that in mathematical induction we have to consider the improvements as a staircase. Okay, as the staircase we are going to move from one step to the other. Okay, one at a time. First step will be the base case. Two of the most important things, the base case and the induction step. Okay, and the hypothesis is just when we are going to substitute k in place of n. The base case will be whether we are testing whether it's true for the first number. Okay, we are just going to substitute 1 in place of n, and in the second step we are going to hypothesis where k is replacing n in the statement. Induction step is the most important one. Over here we are going to check whether we can go from k to k plus 1. Okay, and in this case we have seen that it is true for all three. Therefore we made a conclusion that it is true for all natural numbers. If one of the conditions were not satisfied, we would have concluded that it is not true for all natural numbers. Thank you.